In this lesson, we're going to transition away from linear, quadratic, and polynomial equations, and we're going to look at specifically simplifying rational expressions. So you can see an example of a rational expression down here. Remember, a rational expression is simply an expression of one polynomial over another polynomial. Now remember, linear and quadratics are polynomials as well, but because they're a special type of polynomials, we just call them linear or quadratic. But they're still polynomials, so I have one polynomial, again, divided by another. That's a rational equation. Okay. So the key to simplifying rational equations is our best friend, factoring. Now we're going to focus on one type of factoring this lesson, namely factoring out the greatest common divisor. That's going to be the key in our lesson, the greatest common divisor. So back to our example right here, 6x squared minus 3x plus 12 all over 9x plus 15. So what we want to do is, in regards to factoring out the greatest common divisor, I want to look at every single term in this expression. And what I want to notice is, first I have 1, 2, 3 terms in the top and 2 terms in the bottom for a total of 5 terms. The question I want to ask myself is there any divisor that each of these terms has in common? In other words, is there anything that I can divide out of all 5 of the terms? And secondly, what is the biggest thing that I can divide out of each of those terms, if there is something I can divide out of them? Now I'm looking at each of these terms, and what I notice that they are all divisible by 3. So I can divide 3 out of every term. And we do that by the process of factoring. It's like distribution backwards. Rather than having something out front right here that we bring in, we notice what every piece has in common, and we bring that common piece back out. So we know that that common piece is a 3. So instead of multiplying something in, I'm going to divide something out. So this becomes 3 times, if I divide 3 out of 6, I'm left with 2, and then the x squared. If I divide 3 out of 3, I'm left with 1. So I could write it as minus 1x or just minus x. And then if I divide 3 out of 12, I'm left with 4. Now you'll notice if I take this 3 and multiply it back in, I would end up back where I started. So it's distribution backwards. But I have to do the same with the bottom. Again, factoring out the 3. So 3 divided out of 9 is 3. So I've got 3x. And 3 divided out of 15 is a 5. Again, if I take that 3 and distribute it back in, I would end up at the 9x plus 15. So we've successfully factored out the greatest common divisor. What this allows us to do now is cancel out top and bottom that greatest common divisor. So the 3 over 3 I can cancel out, so that I'm left with 2x squared minus x plus 4 all over 3x plus 5. So it's not a lot of simplification, but we were able to take all of the coefficients, and because they all had something in common, we were able to divide that out, factor that out top and bottom, so that the numerator and denominator, the factors of 3 out front, now canceled each other out. And this is our final rational expression simplified. Let's try that again, but also be mindful of a scenario that people often make a mistake. So here's another example, 10x to the third plus 45x minus 15 all over 25x squared plus 45x plus 60. It is very, very tempting for people to look at this and see that there's a 45x on the top and bottom and go straight ahead and just cancel them out. Unfortunately, we can't do that. The only way we can cancel things out top and bottom is if they're connected to everything else through multiplication. Right now, the 45x is connected to the other terms through addition and subtraction, not through multiplication. So we cannot cancel them out top and bottom. We could only cancel them out top and bottom if it said something to the effect of 45x times some other stuff and 45x times some other stuff. If the 45x's are out front being multiplied by everything else, then I could cancel them out. But I can't because that's not the scenario that I have. So what can we do? We can go back to the initial concept of factoring out the greatest common divisor. First off, count the number of terms. I've got 1, 2, 3 in the top, 1, 2, 3 in the bottom for a total of 6. What is the greatest common divisor? Looking up all these, I believe they're all divisible by 5. So I can factor a 5 out of every term. So doing that, 5 out of 10 becomes 2x to the third plus 5 divided out of 45 becomes 9x. 45 divided by 5 is 9. Minus 15 divided by 5 is 3. Divided by, 5's coming out of the bottom as well. Factoring it out of each term. 5 divided out of 25 is 5. And then the x squared. Plus 5 divided out of 45x is 9x. And then 5 factored out of 60, I believe 5 goes into 60 12 times. So that's a 12. So I was able to successfully take a 5 out of top and bottom. Now I have the scenario where 5 is being multiplied by both pieces on the top and the bottom as factors. So it's 5 times a bunch of stuff and 5 times a bunch of stuff. That's why I can cancel these 5's out, because they are factors now. They're multiplied by everything else. So I end up with 2x to the third plus 9x minus 3 all over 5x squared plus 9x plus 12. And again, don't be tempted here to cross out the 9x's. I can't because they're connected to everything through addition and subtraction. The 9x's aren't out front being multiplied by everything like the 5's were. So this is the simplified expression. I want to take a look at one final example in this lesson because it illustrates one other issue that we have to be aware of, or a scenario that we have to be aware of. So I've got my expression here, a rational expression that I'm supposed to simplify, and we've been talking about it in terms of factoring out the greatest common divisor. So first, let me count the number of terms I have, 3 up top, 2 down below for 5 total terms. Now if I look at all the numbers here, I think 4 goes into all those numbers. So everything is divisible by 4. However, I also see that every term has an x in it. There's no terms that are just a number. Every term has an x in it. So interestingly enough, I'm not going to factor out just a 4 from every term. I'm going to factor out a 4x from every term. So what does that look like in the numerator here? Well, if I divide 4 out of 8, I'm left with 2. If I divide x out of x to the third, I'm down to x squared. So again, think of it as the opposite of distribution. If I were to bring this 4x back in, the 4 times 2 is 8. X times x squared is the x to the third. So I'm taking the piece out instead of multiplying it in. Plus, divide 4x out of this term, I'm left with a 1. 4 divided by 4 is 1. X squared divided by x is just x. X squared dividing out an x again leaves me that x. Lastly, minus 16x, factoring out the 4x. 16 divided by 4 is 4, and x divided by x, they cancel each other out so that there's no x left. So 4x has been divided out. Again, can't stress this enough, it's the opposite of distribution. If I were to take that 4x and multiply it back in, I'd end up with this top piece right here. So let's do that with the denominator as well. We're going to factor out the 4x and see what we end up with. So 4x out of 4x to the third, 4 out of 4 goes away. X to the third divided by x is simply x squared. 24 divided by 4 leaves me with a 6, and x divided by x cancels out so that there's no x left. So I've successfully factored the greatest common factor of 4x out of, or greatest common divisor of 4x out of each term, both top and bottom. Now again, as we've seen in the two previous slides, is that the 4x's are now factors being multiplied by everything else, which means we can cancel them out. And what are we left with? We're left with 2x squared plus x minus 4 all over x squared plus 6. So in this example, we didn't just factor out a number, we also factored out a variable, because every term in the original problem had the variable in it, so we could factor it out.